Everyone, so this is the third video on numerical differentiation. If you look at my previous video, to solve this numerical differentiation, there are two approximations based on Taylor series. You have d1xh and d2xh. So d1xh is a forward difference formula given as half of x plus h minus fx divided by h. So in other words, this is equals to that, which is equals to this one. Now similarly, you can also find df prime x by using d2 formula given as f x plus h minus f x minus h divided by 2h. Okay, so we have two different approximation methods that can be used to find the derivative. Okay, the goal is we want to find f prime x for a given function. Okay, you can find the derivative directly, that will be an exact solution, or you can use approximate method. Now we have seen in my previous video that D2 gives greater accuracy than D1. Greater accuracy means the solution has smallest error. The solution has smallest error compared to my D1. Okay, so D1, this is actually order 1 forward difference, and my central difference here is order 2. Now how do I get this order? So there are a few ways to do it. You can expand the Taylor series and look into the h power. We know that this D1 is derived by the Taylor series, right? So I'm looking at f x plus h by the Taylor series. I have fx plus h f prime x plus, this is h second order, so h2 over 2 factorial f double prime. Now if I want to find f prime x, which will be f prime x is this minus this minus fx divided by h, and then you have this h squared. Okay, so the process here, you can actually see that if I want to find the error or the absolute error, and I can write as absolute of e x h is equals to my d x h minus f prime x. Okay, so by doing this, we can see that, so I can write this is my d. Okay, in other words, my d, okay, x plus h minus fx divided by h is my f prime. So my d minus this, so my d minus f prime x. So what is my dxh? This is equals to f prime x. Okay, it's right? Because this is d. But then we have something in the power of h squared here, so I can write as chp, where c is a constant, and this h to the power of p depends on your p here. Okay, so if you're looking at second derivative and so on, your h will increase. Okay, so now since what is d? dx h minus f prime x chp. So therefore my arrow here, exh, which is this minus this, which gives me ch to the power of p. Okay, if I take the log, left and right log, so what I get? Log exh equals to log chp, which I can also simplify this as log c plus product property for the log. I have p log h. So if I plot the graph of log of error versus log of h, okay, you will get a straight line, and the slope should be the order. Okay, slope is the order of the method. So by doing this, we can observe that the log-log plot gives you the log-log plot of error versus log h gives you the order of this d, and so we can get d is order 1, d2 is order 2. Okay, so the other thing that I want to say here, on my previous video, I have shown that if the combination of 2 d1xh over 2 minus d1xh gives greater accuracy than d1xh. Okay, this combination you can try by using example mana. For d2 we have 4 d2xh over 2 minus d2xh divided by 3. Now where these numbers came from? So this is what we want to see. Okay, today's topic, extrapolation. Okay, extrapolation technique. See, extrapolation technique is a way to improve the accuracy of the approximation by using two different h over 2 and h over 2 and h. So if I have a table here, this is h over 2, h over 4. Okay, and I can start with, this is my T11, T21, T31. This is T22, T32, and I can even go further. Okay, so this is the extrapolation formula. This column, the first column of my T here, can be obtained by D1 or D2. Okay, you can use D1 or D2. Now this T22 here, this is where we use extrapolation. Okay, for D1, T22 is obtained by 2 times T21 minus T11. T32 can be obtained by 2 T31 minus T21. And lastly, my T33, to find T33, okay, so let me write T22. T22 equals to this, and T32 equals to this. Okay, to find T3t, if I'm using D1, okay, I will have 2 to the power of the order will be 1. So this is 2 to the power of 1. So I have 4 T32 that we have obtained here minus T22 divided by 3. Okay, so let me just explain here. This is D1, this is order 1. So this is order 1. Okay, this will be order 1. My T3t will be order 2. The order with extrapolation for D1 will increase 1 at a time. Okay, now for D2 is order 2 and is symmetric. So since it's order 2, it will start with 4 and 3. So to find T22, I will have 4T21 minus T11 divided by 3. To find T32, I will have 4T31 minus T21 divided by 3. And then to find T33, I will have 16 T32 minus T22 divided by 15. Now where do I get all these numbers? Okay, so extrapolation technique. There's lots of history for this, but it's simply based on this equation here. So extrapolation, so we have 2 to the power of p. Okay, so T H over 2 minus TH over 2 to the p minus 1. Okay, this is the standard formula for extrapolation. Okay, this can be T to the thing is, this must be half than this. So you can have H over 4 minus H over 2. They'll be the same thing. Okay, so for D1, since it's order 1, P is 1, so that's why I have 2 in the front here. Okay, because 2 to the power of 1 is 2 minus 1 is 1. Okay, so when you come to T33, the order will increase by 1. So I will have order 2 here. So 2 to the power of 2 will be 4. 2 to the power of 2, 4 minus 1 is 3. Okay, now for D2, this is order 2. So for D2, this is my D2. Okay, I have H over 2, H over 4, T11, T21, T31, T22, 332, T33. Okay, D2 start with this first column here, which is by using D2 formula. So this is D2 formula, and then you will use P equals to 2. Now this one here, okay, this thing here, my P will be 4. Because the method is symmetric, the order will increase 2 at a time. Okay, order will be increasing 2 at a time. So that's why you have 2 to the power of 4, 16, 2 to the power of 4 minus 1, 15. Okay, so these are this is about extrapolation. I hope you understand. We'll try to look into more videos next time. Bye.